Welcome back, everybody. In this video, we're going to be taking a look at our next topic when it comes to MPLS Layer 3 VPN, and that's going to be Ospf as the PE to CE routing protocol. Now, as we progress into this, there's some interesting aspects to Ospf that we need to take into consideration when we're actually dealing with MPLS and Layer 3 VPN, especially PE to CE routing. Now, initially set up, we don't have much to worry about configuration-wise until we get into a little bit further on down the road. And we don't really have to worry about that in this video. It's just more about, hey, just be aware of some stuff in the future, and I'll call those things out when we get there. So what we're going to do is we're going to take Ospf and we're going to replace ISIS here between CSR6 and R15 and XRV9 and R14. That's going to be our plan to attack right now. Configuration, just like we've been doing, is set up the PE to CE connectivity first on both that connection, the PE to CE connection, and then work on our mutual redistribution once the routes have been learned on the PE side inside of the VRFware routing. So let's go ahead and kick this bad boy off. So we're first going to start on R15, and I'm going to go ahead and type in router Ospf 15. I'll specify that the network command of 101.6.15.0, 0.0.0.0.255 area 0, and network of 10.1.15.0, 0.0.0.255 area 0. Now we'll go over to CSR6, and I will go to global config. Now we're using Ospf in the core, okay? So because we're using Ospf in the core, we actually cannot reutilize the process 100 process for the VRFware component. We have to use something else. So I'm going to go ahead and type in router Ospf 6, because we're on CSR6, and then you have to add the VRFware syntax. So VRF C1. Then you can come underneath here and type in network of 101.6.15.0, 0.0.0.255 area 0. Now let's give that a couple of seconds, and we can see that we form an Ospf adjacency. If we do show IP route VRF C1, we're going to see that we're going to learn the 10.1.15 route in. And you'll notice that the other route shows up as this one shows up here too. Well, that's because the way that Ospf allocates itself, it only points itself to the loopback. So one thing that we could try to do, I haven't tested this out though. Let me just double check to see if it's updated itself. Yeah, I don't think it's going to. We wait till the 40-second time frame. What we can do on the Yep, it looks like it's not going to do it. So what I can do is on CSR on R15 interface loopback 0 is I can type in the command IP Ospf network is point to point. See if that'll help resolve that problem. And I'm not sure if it's going to, and there it did. So now what we're going to see in the routing table is just the prefix, the /24 prefix. So before we were seeing the /32 because by default Ospf will allocate a /32 address for any loopback addresses to treat it as a host route. Well, that was still allowing ISIS to propagate the /24 as an ISIS route. So it was a little misconcerting. It can be a little tricky to troubleshoot. But on R15, by changing the network type of network point to point, we basically say we're going to take and we're going to flip it over. So we want to advertise it as the prefix as it is and not as a /32. So if we were to look at the show IP Ospf interfaces brief, we're going to be advertising it as a /24 and not as a /32. So if we were to go to interface loopback 0, type in no IP Ospf network point to point, and then do show IP OSPF interface brief. Once it clears, this should get advertised on CSR6. We'll see this show up as a, we can see that the ISIS route is now back, and the loopback address itself, let me do it this way, show IP OSPF interfaces loopback 0 detail, interface detail loopback 0. Yeah, see, it's showing up as loopback, and if we change that to interface loopback 0, IP OSPF network is point to point, and do show IP OSPF interface loopback 0, we'll see it now show up as a point to point, where before it was not. So then by doing that, it shows up as a point to point network as a /24 prefix, and CSR6 will see it as a /24 now instead of a loopback. Instead of a host route, it shows up as the actual prefix that was advertised. So that's one of those things that you can do to get around the MPLS layer, the LDP aspect of how OSPF handles things. I'm not going to get into that now. I'll focus on that in the LDP set of videos, but that's one of those things that you can do to get over that /32/24 issue that's there. Now that I had the route learned there, I'm going to go over to R14 to the exact same thing. I'm going to go to router OSPF 14, network of 101.9.14.0, 0.0.0.255, area 0, and then network of 10.1.14.0, and get all that squared away. And then I'm going to go over to XR9. I'll type in router OSPF and then 9 here, VRF C1, area 0, interface gig 0000, I believe it's 2, and it is 2. I'll go ahead and I will commit that config, and momentarily we should learn an Ospf adjacency with 14, and we'll be able to go from there. So we should get an adjacency up here in just a minute, which we do. Let's go back over to XR9, and we're going to do show route VRF C1, and you'll notice that we have the same problem, right? We're still running into the same problem where the /24 comes across as a RIP route, but the host route comes across as a host route. So interface loopback 0, IP OSPF network of point to point. Go back to 9, and then we'll see it show up as just a /24 route, which is what we want. Now that we have the CE loopbacks being learned inbound on the provider edge routers in the VRF aware routing, now we can do our mutual redistribution. So on this configuration, we'll be able to go in here, and at the VRF level, we'll be able to go ahead and redistribute BGP 100 and hit the enter key. That's all we really need to worry about here. And do that. So router BGP 100, VRF C1, address family IPv4 unicast, redistribute OSPF 9, and we're gonna have to match on some traffic. So what we'll have to do, and I'm actually just going to hit the enter key and commit this command, and you'll see what I mean here in just a minute. We'll have to go ahead and we'll commit that configuration. I'm going to go over to CSR6 and do show BGP VPN v4 unicast all. We should be learning the 14 prefix And you can see the metric is being learned. We are learning it appropriately. And now what's interesting about this whole setup is we're going to be learning some additional commands in here. I want to finish the config first and show you how some stuff is actually going to play out. So let me go do the redistribution on CSR6 first, because the last time I checked I was underneath the, let me exit out of here and do the, we'll type in redistribute BGP 100, and I'm going to say subnets, and hit the enter key, and then router BGP 100 address family IPv4 VRFC1 redistribute OSPF. In this particular case, it's going to be 6, and hit the enter key. Now, if I go over to XRV9 and do show BGP VPNv4 VRFC1 unicast VRFC1, I have the 15 route coming across, and I am learning it. Now, what I want you to pay attention to is right here. Notice the domain ID is coming across here, but over here, we don't see a domain ID. The reason why is the domain ID by default does not come across. Now, what is the domain ID? The domain ID is going to be derived from the provider edge, OSPF process ID number. So in the event that this is, so right now we're using XR9 and CSR6, so we're using OSPF process 6 and OSPF process 9. What will end up happening is the routes on the CE routers will show up as OSPF external type 2, where if you were to use the same process ID on the provider edges, say 10 and 10 or whatever the case might be, then the routes from the customer edge would show up as OSPF external, OSPF in inter area, where the provider edge routers would act as like an area border router into the rest of the service provider backbone, where the service provider backbone would basically act as a very large area 0, and every provider edge router that connects down to a CE running OSPF, the provider edge router would appear as an area border router, and they would propagate a type 3 LSA. Now, what's going to end up happening is I have to go over to XRV9, and if we go over to R15 and do show IP route, we're going to see OSPF external type 2 routes. Same thing with 14. Do show IP route, we're going to see OSPF external type 2. And I'm expecting to see that because the domain IDs are not going to match. As a matter of fact, on CSR6, I actually have to, I'm sorry, on XRV9, no. I have to grab this information right here later on. So what I have to do on this guy is I actually have to go back to router OSPF 9 VRFC1 and specify the domain ID. In this particular case, the type is going to be 0005, and then I have to specify the value in hex that's going to be taking it, so which is this one right here. Right here. So I have to grab this detail right there. Now by doing this, if I do a show config, that's going to be the command that I type in. So I'm going to go ahead and I'm going to commit this, and you'll notice the value is 6, right? So that means that it came from 6, so CSR6. If I hit the commit command, now I go back over to CSR6 and I hit the up arrow, you'll see that the domain ID came across as 60,200. So what should happen, theoretically speaking, is now the routes will come from, because the domain ID now matches. Now, Originally, the domain ID is derived from the OSPF process ID on the provider edges for the VRF-aware process. Now, in the event that you change the domain ID to match, you'll notice that the route from 14 comes across as a inter-area route, and now 15 should show up as an inter-area route, which it does. Now, because it does that, that's a great sign. Now, if I went to CSR6 and I was to modify, or XRB9, if I was to modify this value to be something else, let's say I came in here, I did a 9 for process ID 9, and I was to commit this, that gets propagated. I go over to CSR6, I hit the up arrow, I see now 9 is propagated right here. I hit the up arrow, I go over to 5, and now the routes will come in as external type 2. Now, it's important to understand the construct and how that actually takes effect, because if you don't understand that process, that could be a big problem. So let me go ahead and reiterate what I just mentioned a minute ago. Actually, let me do a quick trace route, make sure everything is working the way that it's supposed to. I'll move the domain ID back to something that's the same. So let's do a quick trace route to 10.1.14.14, sourcing from loopback 0 numerically. Do I have reachability? I do. And I'll do the same thing for 13 and 13. And I have reachability there. So let's go ahead and rehash this whole MPLS configuration wizardry stuff that I just mentioned. So basically the idea is this. Right now we're running area 0 here and area 0 here. Right? Everybody can agree upon that. Now, inside of the MPLS backbone, we're running OSPF internal for the IGP routing. So what ends up happening now is, remember, we have our PE to route reflector and PE to route reflector configuration, right? And then we have so we have all of our IBGP peering set up, and then we have via a path here, we have an end-to-end LSP. So the red line is our label switch path. The yellow lines here inside are going to be our IBGP peerings to the route reflectors. Everybody can agree upon that. Now what's happening is, and I'll switch over to like sky blue. What's happening is basically for this configuration right here, this big blue oval that I'm drawing, this area, the service provider backbone, the provider edges are joined together through basically this point-to-point connection that is area 0. From an MPLS perspective, the service provider acts as the super backbone, or a hierarchy level above what the provider edge to customer edge area 0 is over here. So this is also area 0. So is this. This is area 0 as well. But because the MPLS backbone is interconnecting these sites, the provider edge routers here are acting as area border routers. And in the event that the ABRs on the connection interfacing the CE outbound here and outbound here, in the event that these guys are running the same domain ID or the same, so if the process ID is the same, is equal, then the routes that are advertised or learned that are processed down this way and learned on the customer side are going to be OIA. If the process ID is not the same, then this is equal to this one. The routes will show up as OE2. So that's really important to understand. The process ID is going to be immediately derived from, or the domain ID is derived from the process ID. If the process ID is not the same, then as you saw just a moment ago, the domain ID is not going to be the same or not even advertised. iOS XR does not by default add the domain ID. You have to add it in yourself. So to that avail, you have to make sure you add it in there. The process ID itself is advertised is derived from the process ID. If the process ID is different on the PE routers facing the CE connection, then you're going to have OE2 routes. So to fix this OE2 stuff, I have to go onto the command line again on XRV9, and I have to hit the up arrow and plug in this value right here so that they're the same. Or I could give it some other value. It doesn't have to, it has to match. So if I just do this, I go over to CSR6, I hit the up arrow, you're going to see that turned to 6. I go to R15, I hit the up arrow, you'll now see that the route from CSR6 that was advertised to CSR6 from XRV9 from R14, so R14's loopback, now shows up as an inter-area route. So that's the real big deal here that we want to make sure we understand. The hierarchy can be confusing, and actually if we look back on CSR6 and we look at the show IP OSPF and we look at the process ID 6 right here, we'll go ahead and clear this off. You'll see that connected to MPLS VPN super backbone VRFC1. Now iOSXR does not give you this output. If we come over here to this guy and do a show OSPF and we look at 9, we look in here, that output is not present here. I spent a little bit of time one night looking over this stuff. It does not show up. If it did, it would show up underneath the NSSA area on 9, and we can see that there is no output here. There isn't really even any more detail than what we already have. Are there other details we can look at? Sure, there are. But in this particular case here, the information that we have is as far as we can take it. That's all the information that we have available to us. So what we want to make sure that we understand in terms of operations here is that we are connected to the MPLS VPN super backbone. The super backbone, in simplified terms, is just a hierarchy above the Area 0 connection. So because what's actually happening is, by default, whenever OSPF works, you need to have a way to take the disparate or the non-directly connected Area 0 configs or domains, and you're relying on BGP to provide the interconnectivity. Let's talk about this a bit more in detail here. In the event that, let's pull my pen tool back out. Let's say in the event that, let's say that we weren't running MPLS VPN at all, right? Let's say that we're running Area 0 here, and then we're running area, actually let me do it this way. We're running another area here and another area here. We'll say this is 0, this was 20, this is 30, okay? What's going to end up happening is, let's say this prefix here, and then anything attached to CSR3 that's a LAN segment is advertised into area 20. Then XRV10 would act as an area border router, and XRV10 would advertise any routes from area 20 as OIA routes, OSPF inter-area routes, because they would just point the traffic towards XRV10 and everybody would be happy. That's just the normal progress or the LSA recursion process of OSPF. Now, what's going to end up happening is CSR3 and XRV9 are forming a pairing, and CSR3 is, he's tickled, he's learning routes, he's good to go. But what's not going to end up happening is he's not going to propagate those routes to XRV10. So to fix this, we have a couple of options. The number one option is to go from the loopback. Let me switch colors real quick. it froze. From the, one moment please. Alright, well apparently my pen tool just died, so that sucks. So let me just kind of reiterate what I was trying to explain. So if you have a situation where you have an area, actually let me draw this a little bit better. You have a situation where you want to draw, you have an area here, you have an area here, and then you have another area here. This area right here is discontiguous. So in order to fix that, you would actually need to go and you would need to, from the loopback to the loopback of these devices, so from XRV10 to CSR3, you would need to build what they call a virtual link. And that's going to be a point-to-point control plane. Think of it like a unicast point-to-point control plane jump. So you're basically extending area 0 over a non-zero area to what would be an area border router. So you're basically extending area 0 over this non-area 0 area, and what's going to end up happening is now CSR3 would basically be an area border router bordering that, and then you would be able to learn these routes. The same concept is happening with the configuration of the super backbone. So here I have, you know, XRV9 and CSR and R14 in an area, and then I have CSR6 and R15 in an area, and then I have this connectivity between these two guys, XRV9 and CSR6. So what's happening is I need some way to be able to take routes from this connection here between R14 and XRV9 and CSR6 and R15 and be able to bridge them together. Well, all of those attributes and stuff like that that are trying to be exchanged between the provider edge routers through the MPLS VPN service, the IBGP VPN-v4 extended community attributes are taking all of those values and then propagating them to the remote PE router through in this case through a route reflection type of setup. In order for the correct routes to show up on the CE side, and this could be, depending on the situation at hand, this could be really, really important. In order for this to work, you would need the domain IDs to match in some cases, where you might have a backdoor link between a couple of locations where we have a connection like this. And we're going to talk about this more in detail in later videos, because I wanted to cover at least the base functionality first and then dive into some of the more complicated aspects of it. But in most cases, what you're going to end up doing is, if you, let's say CSR1 and XRV9 both paired with AS10 here, then R13 and R14 had a backdoor link configured. You may want to prefer the MPLS VPN connection over the backdoor link for whatever reason. And there are reasons for that. We'll have a discussion as to how that would work, where you would need to make sure that the domain IDs would match on these PE routers, or the process ID for the VIR for OSPF configuration is the same, so that R13 and R14 would see the same routes coming in as OSPF inter-area, so that you'd be able to do your traffic engineering effectively. And then we would configure a sham link and things like that. That'll be coming up in an upcoming set of videos, but I wanted to give you an example of how that would work. But that's just that's some of the more complicated aspects of how OSPF comes into play when it comes to MPLS Layer 3 VPNs as a PE to CE routing protocol. With all that said, I'd like to thank you guys for hanging out with me in this video, and until next time, guys, take it easy.